Section 5.2 is using perpendicular bisectors. We have a drawing of line segment A, B, and we have perpendicular bisector N. We know it's a perpendicular bisector because it is perpendicular to line segment AB, and the two sides of the line segment are congruent. We have a perpendicular bisector theorem. Any point on a perpendicular bisector is equal distance from the endpoints A and B. So once again, we will draw the perpendicular bisector, and this is the bisector of line segment AB. And this property says that any point on this perpendicular bisector, these are all equal to the endpoints A and B. So these lines are congruent. These lines are congruent. These lines are congruent. You can see that you are probably making lots of congruent triangles. You can use this property in extra example 1. In the diagram, RS is the perpendicular bisector of PQ. So we know that RS is perpendicular to PQ. We know that these sides of the triangle are going to be congruent because it's a perpendicular bisector. So given that, we have that this is SR is congruent to SR because of the reflexive property. So we have two triangles that are congruent by side, angle, side. If these two triangles are congruent, then PR is congruent to QR by corresponding parts. So we can say that the two line segments are congruent. 8x minus 9 is congruent to the other length of the line segment, 6x. We say that 8x equals 6x plus 9, adding 9 to both sides. We subtract 6x from both sides and get 2x equals 9. Divide by 2 on both sides, and we get x equals 9 halves. I'm not going to simplify it because I need to not find x. I need to put it back into one of these congruent sides in order to find PR. I'm going to take the simplest and say 6x equals 6 times 9 halves. So this cancels. And I'm going to get x, 6x, is going to equal 27, 3 times 9. There's another very unique thing about perpendicular bisectors. If you make a scalene triangle, and we're trying to do a scalene triangle means that none of the sides or none of the angles are congruent. If we draw this scalene triangle here, and we take the perpendicular bisector of all sides. So here, on the side here, we have a perpendicular bisector on this kind of top side, which is red, and it's going to be equal distance to all the points on the sides of that perpendicular bisector. We have a green perpendicular bisector here. This is going to be the green perpendicular bisector, and it's going to be equal distance to all the points on its side. And last, we have a blue perpendicular bisector, and it's going to be equal distance. So all points are going to be equal distance to this center point, which means this is a concurrent point, or we call it a point of concurrency. And this point of concurrency is called the circumcenter. There are other points of concurrency for other types of lines, but when the perpendicular bisectors meet at the center of a triangle, it is called the point of concurrency, which means they're equal distance to all the endpoints of the triangle.